9 people, perfect. 9, we wait a little bit. Let me, okay, so take your, you should have all the document. So we have plenty of stuff to go through. It's a bit long, the prac, but no worry, you have the code and I will give the solution after. It's just today, the aim, the goal is to practice with different parameters of your neural network and to be comfortable to run a neural network with different kind of layers, unit, with dropout, with batch normalization, and we played also with weight initialization, all of these parameters. And we will see today that, in fact, neural network is quite an art to design neural network because there's a number of layers, the number of units, there are some hyperparameters for the learning process, like the learning rate, if we add dropout, what kind of weight initialization I use, what else? Patch normalization, all of this. So you will see that today we just play with a kind of a grid search, and after we will see some more advanced way to calibrate well your neural network. That's the goal of today. Okay, we keep going. Okay, so I will open also the work today. So all is on the website. Huh? I will do the same job as you. The website, the track, and you have the archive also. So let me know if you have any trouble. I will share the screen maybe, and you will also share your screen sometime. Okay? Well, it's good. We are just 9. I don't know if it's good or not. You know that at the end we will have a challenge. I was talking about this with Yoni and Sarat. We got a challenge. We need to build Python and Julia. We got like a kind of data set, and we try to build the best neural network to have a goal, a task. And we do in Python, Julia, and R by group. This will be our last game, and so we have to beat them. So I need to train you well. Okay, so where is share the screen? Share the screen. Share the screen. This one, yeah. Should see. Share. Okay, so you should see my screen. Is it? Yep. You see my HTML? Okay. So we, in fact, today we mostly work with MNIST data. So the MNIST data is in the package is in Keras. So let me know if you have any trouble to get the data. So you should have, you know, this data now, 60,000 digits. Yes, let's check 10,000. And we still first step, we scale the data. There's a percent 0 to 55, so we get all the figures between 0 and 1. And you can see this nice, just to be sure that everybody understands, you see this nice function which is called toCategorical. So it's a function to from class. From a categorical variable, it creates 10. If you have a categorical variable with k categories, you will create k indicators, like a matrix, and with a 1 for on which class you are. So which is code, which is named the one hot uncoded. Make sense? So I'm not sure if I use it, but sometimes some package need this for the network. Okay, so we will what we have two hidden layers. The first one with 128 neurons, the second one 64, and the last one is the output is 10, because you have 10 you have 0, 1, 2 until 9. And so the input data is for each image we have 20, what is it, 28 by 28? Yes, 20, no. Remember 28 by 28 is 50, oh, it's 50 by 42. Oh my god, I'm bad in multiplication. Yes, 28 by 28. So as I told you yesterday, most of the time, the most popular activation function for hidden layer is the ReLU. So I use the ReLU. You see the code? So layer dense 128 unit. Input shape. The argument is in fact the input, which is the first input, so is our features. So I just use, instead to put 784, I just take the number of column of my data. Okay? And after, in fact, this input shape, you don't need to put it, because we know that layer dense come to the over one. So we will know that the output of the first hidden layer will be 128, because I have 128 units. So this 128 is kind of my new input for the second hidden layer. Make sense? Everybody got it? Okay, so after this 128 come the second layer, the output is 64, and this 64 go to the last layer, and the output of the last layer will be 10. And for the activation function for the output layer, make natural to use the softmax, because it's a multi-class product. Okay, we have a question. Okay, so chat to arrive. I don't know why we chat. This is okay, sorry, let's see the question. Yes, I will when I speak. I'm fine. Hi, Benoit. So we do not write the code and what we want? 2.21. I just, okay, yes. This, it was just to explain, we don't run this code at this stage, I think. Okay, yes. It was just to explain how to set up the 2.2.2. It was just to set up the activation. But after we need to do more, because we need to also now, after, we need to compile the compile part is about the loss function and the optimization part. Ah, you have an echo? I'm getting an echo. Where's the echo? Yes, good question. The bias is always by default. You don't need to specify the bias. And it's a good point. You will see the number of parameter after. So in compile, you have different arguments. You have the loss function to use. So here is natural to use categorical cross entropy, but you might use another loss function. The optimizer, I choose this optimizer, but you can use Adam or whatever, just a default, a different optimizer. And after the metric is the metric is used to show the result. So I use the accuracy. To show the performance. So if you run this part on 2.23, you will get after a wide summary of model, you have a summary of your model, which is quite nice. The summary of the model gives you the number of parameters. So you have this total number of parameters. Okay. So now we need to. So this is a setting of your model. You haven't run anything. It's just a setting. So now we need to train our model. So to train our model, remember that in the learning process, we will in fact split the data. At the beginning, we move some test data. So the test data we put aside, we never use now, okay? And now for training our model, we have still the training data, but in this training data, we will use a part for the optimization, okay? And you have a part, which I said yesterday, a validation part, which is used to evaluate your model, which has been estimating on the train data. And why we do this is just to not overfit, because if you go too long the optimization on the train data, your neural network will fit completely your training data very well, but not very well for generalization. So we see this. So in this part is, you can see my mouth, I highlight this validation split. So it's the meaning that 20% of my training data are used in the validation set. The validation set is completely different as a test set, okay? So 20% are there. Verbose is to show your result step by step. If you put true, in fact, it will, you can do this, maybe it could be long. It will show the graph in live in RStudio. You can draw it. So epoch, you now remember, I just put 25, epoch. And this is, somebody can tell me what is this argument, batch size? What's the meaning of batch size?
It's the number of data points in each, the number of data points in each epoch, in each batch that feeds through.
Yes. Okay. Yeah. So this is the meaning that we use the mini batch approach. So is the size of your mini batch, and for example, how many question? Oh yes, I put it here. You can see the reminder. Reminder. An epoch describes the number of times the algorithm sees the entire data set. So if we have a batch size of 128, one epoch is achieved after 375 pass. So move of the pass is a move of your algorithm. So it did 365 until it has seen all the entire data. So this will be one epoch. And after I do 375 moved, and so on, and so on. Okay? And so we have this output. How it looks. Did you get this? Everybody managed to get this? Yes. Have you tried to do this? I don't remember it was long or not. Have you tried to do this with verbose equal true? Maybe try with verbose equal true. Try it. I hope you will not stuck your model. So what happened when you do this? Ah, every time I try running this part. Yes. So Anne gave you the solution. So it does the update on the screen. So be careful, because sometimes if you run a very long process, it will be forever, because each time you need to print. So sometimes it's better to put false. Okay, so machine has a trouble. Every time I try running, you are on RStudio, machine. Machine. Yes, I am. My R session expire. Could you share your screen very quickly? Okay, I will stop sharing my screen. Okay, but before I will stop sharing my screen, I just, because the people maybe we keep going. So I just want to say something before I try to add machine. Okay, if you look at this graph, what is important? I was saying yesterday on the lecture, you can see the training loss. The training loss, when you have more iteration, is getting better, is improved very quick, very fast. And you can see that it's going down. So one issue, it will be if you stop at 25 and you take your solution at 25 as your model. So at 25, you have the solution of your weight. If you use this model, I am pretty sure that it will be not a good model. Why? It will be not a good model. You need to write something on the chat or tell me. Yes. It's not because the test, yes, the test loss is high. So I prefer to precise, it's not the test loss, it's the validation loss. The test we haven't used, but maybe it will be higher too. Why is overfit? Because you can see that the loss function of the validation is going down, so it's good, and on one stage it doesn't improve anymore, like a plateau, and after it increase. So it's a meaning this that your weight are really related to your training data, and not so good now for the validation, because the validation is some data that your model haven't seen. Okay, similar with the accuracy, is the same, because you can see that the accuracy improve very fast for the training, and after it's very close to 1, and after it's completely 1, so it's really, that is perfect. But for the validation, is quite okay increase, and after I stop, it's like a plateau, it doesn't move. Okay, so maybe it will be better to stop around something around 10 epoch or something like this. So we will explore this, but it was important to understand this. So after we have a, yes?
Can I ask a question?
Yes.
If you go back to the figure you just had, yeah, that one, figure 1. So when we train the model and we specify epochs to be equal to 25, the model we're actually going to use and going to predict on is using 25 epochs now.
Yes.
Okay, so it doesn't select the best one based on the loss. So we actually have to specify how many epochs. Okay.
Yes, but we'll have, it's a good point, we have also, which is called the early stop. There's an option which is called early stop, which you put early stop and you put the number of epoch. So it's a meaning that as soon that your validation test doesn't improve anymore about 5 epoch, it stops.
Yeah.
For you.
I have another question. With the with each epoch, is the order that the data is fed into the fed through the model, is that the same, or do they reorder the data in each epoch?
If I have to do by myself, I will reorder at each epoch because it's a stochastic, so each time is shuffled. So
Okay, yeah.
It's not it's not the same mini batch type.
Yeah, that's what I mean. Okay, cool.
So after you have a function which is called predict class. So based on your data, so now I use the test data, which I haven't used. Okay, something I never used, not for the validation, nothing. So the new data, and I can use predict class if you give the features. I did for the 10 first, and this gives me the prediction. And if I am looking at the true label, it looks good. So there's just one error. It was for the 6. He predicted 6 here, and it was a 5. You can see for the 10 first. But we want to see for all. Okay. And by the way, you know, in R, what is the meaning of this symbol?
It's like an operator. Use this function on this element. Yeah, so it's the dplyr thing.
Yeah, it's called the
pipe operator.
It's a pipe operator. So it's nice because it enable us to have something short not to store in a new object. So it's the meaning that model here will be the first argument of the next one. And the next one will be the first argument of the next function. So instead to write predict class, bracket, model, comma, and so on, I put model. The model is going through this function as the first argument. And this output, if I put again a pipe, I could have put this pipe there to go all of this going on the first argument and so on. Make sense? Okay. So I did this table just to see this is called the confusion matrix. Make sense? The confusion matrix. And I compute the accuracy on the test set. Pretty good. You can see that we did the job. Remember, we can do this job by doing 1 versus all and all this, but we did this very quickly. And on this data, 97% accuracy. Okay, and that's a nice package maybe on machine learning, which you should know is the package. Some people say carré, me I say carrot, I don't know. Library carrot, and there are nice function, and you can build many machine learning tools. You do also the cross validation, you do the random forest, boosting tree, support vector machine, all of this. But here I just use this to compute the confusion matrix, because there are a nice function which is confusion matrix, and you put your prediction, and you put the true, first prediction to the true, and it gives you many. I just plot the table, but if you put res, if you type res on your screen, you will have many results, not only the accuracy, but I wanted just the accuracy to see if I compute well the accuracy, and I compute well the accuracy. Okay. Okay, I'll let you wait a little bit. I need to go, and I need to reply to machine. Just I come in 1 minute. Somebody asked me something. Keep going to this part, to read this part. So this part is the meaning that we will try different model, different complexity. So depending the number of hidden layer. So I will try a model with 1 hidden layer, a model with 2 hidden layer, a model with 3 hidden layer, and with a small number of neurons, a medium number of neurons, and a large number of neurons. So it's meaning we have 9 models to explore to see which is the best. You see my point? So for example, if I am on this case, which is the meaning that my first hidden layer has 64 units, my second hidden layer has 32, and my last hidden layer has 16. Yep. So this gives me a kind of complexity of my model. And we have seen yesterday, more your model is complex, and we maybe have a higher capacity to learn about complicated relation between your features, your input and your output. But sometimes it will be too overfitting, so it's not meaning because we have the biggest model, but it will perform well because when you have a big model, you have a lot of parameters to estimate it. So it will be harder to estimate, and you can be stuck in some minimum local and so on and so on. So it's not the meaning that if you put the larger model will be the better. So first I did a small model with one layer, and then you have the code, and after I think you have a question. I did this for the first, you have the code. So this I manage, okay, maybe it's an ugly code, but give you for the model with one layer, you have the small, medium, and large. You understand the small, medium, and large, and I compare the validation error and so on to see which is the best, is there some overfitting and so on. So your first task is to do the same for the 2 layer and 3 layers. And you should have something this at the end. This is the solution. Try to get this and come back and I help the machine. Rashid, can you? I try to help you. Do you get the same trouble?
Hi. Yes, I tried it 3 times, and every time I try training the model, my R session expires.
Can you show me? You are on Mac, huh? Is it?
Yes.
You managed to install last time we got some trouble, so you managed to install a Sarat for this?
Yes, I could do that, and I don't have any problem with the previous practical. All the code worked well.
Yeah.
But now, when I try doing the modeling,
Can
my
you
R
share the screen?
I cannot, I couldn't, but now that you stopped sharing, maybe I can. Yes, I can. Can you see my screen?
Yes.
So until here, it works fine. But when I try running this part, should I try it?
Yes. Come in.
You have the paperwork for the supplementary exam that you marked, the one on Tuesday.
Yes. Sorry.
You have a paper copy of it. Yes.
Ah, okay. So session aborted. So, okay, I got it. So we open. I think maybe I have. Okay. Sometime. Oh. Ah. The weight performance. Push or CNC position. Oh. No, initializing Libya. You look like something that something is running on your computer already. Okay, can you abort it, this? And open close RStudio completely. Yep. Can you open again RStudio? And I will check something. Oh, this one. Okay, I need to find the code, what I put. I see there. Okay, come, yes, try to do again, step by step. Okay, you don't need this, okay. Yes, you need this. You are not lucky each time, huh? I did trouble like this last time or not? Ah, yes. Okay, you have done this, don't move, okay. I was looking, you did a clear session or don't do it this time?
Okay.
You have done this last time?
I haven't done it. It's working, and
Yeah.
so I shouldn't run this part and go to.
Don't do this. No, don't do this.
Okay.
It's because is because you have built 2 times the model. So this time we don't need to run this.
Okay.
Maybe do this one. Yep.
The activation argument.
Yes. So this now you have your model. Okay, perfect. Go down. Oh no, sorry. Yes, don't do this. Just the compiled part. Yep. Yes, it will be not working. Okay, you need to put just before the pipe. Take the pipe also on the top, just before the compiled. Sorry, just yes, put the pipe. Yeah. No, it's a mistake.
Oh, it's the other way. Sorry.
Yeah, it didn't work because okay, sorry, it's a mistake. Okay, so you need to clear the session first. So sorry, come back up, top. Yes, yeah. Yes, you clear the session. So now you can do not this part, the model with the compile. Yes, all of this part. Yes, my model. I hope. Okay, you have just one model, and I hope you'll be okay. Of course, huh? You was doing this last time?
Yes.
Oh.
This one has a problem every time. Yeah.
Oh my God.
It's okay. Maybe you guys go ahead. I keep listening, and then after the class, I try to figure out what to do.
Try to Google the two first.
Okay. Thank you.
Right. Will be a hard chapter. Okay. So how is going? Sober. Is going well? Not well? Is working? So where you are now? Okay. So did you manage to get something like what I have? Yeah. Something like this? Yes? Somebody got it or something like this or not? No, not this one maybe. I don't remember. Not here. Okay, so task one. Task one. You managed to use task one? Yes, perfect. We have one yes. So for example, do you have still some overfitting? What do you think? Task 2. What are your conclusions from this experiment? Which model presents some overfit issue? Which model to keep? There's some randomness, so maybe you don't have the same as overfitting issue. Okay, bottom right. Yes, true. You know, because it's a large model, complexity large, capacity large, so it go very quickly to overfit. Because you can see that validation error start to go very up, but maybe it's still a good model. In fact, the good model, it looks like a large, because the last row, every time the minimation, I just print the minimum of the validation error. So it's the meaning is the minimum of the green curve. And you can see this each time is for a large model. But it looks like for this one, for example, is one layer is enough. So one layer at this experiment, one layer with this number of neurons is quite good. So this was the model with one layer and 256 units. Make sense? Okay. So now we have seen in the lecture that sometime to improve, it will be, we say, batch normalization. So I put here the example of the batch normalization. So the batch normalization is to have some features which, so most of the time, before 2015, the good process was to do some normalization of your input data. Okay. So on the input, it's quite normal to do some initialization to have that each input has the same influence in your model. Okay. But the good improvement is, in fact, when you do the input, you go through the first layer, and at the output of the first layer is coming as kind of input for the second layer. So the meaning that as soon as I finish the activation function on my first layer, I can do some normalization also. So this is in the code, you can see this is with layer batch normalization. You see it? Everybody? So I add a layer batch normalization after each layer. So this is just an example to how to do this by code. So I add a layer batch normalization after each layer. And I will see if it's improved my model. So, oh. Yes, I put an example, but it was just to play. In this model, how many parameters I have?
So there is in the Keras package, they split it up into parameters that you can train and parameters that you cannot train when you have the normalization. So for the parameters in total, it's 200,400. I'll just print the number.
Yes, so the parameter what I like is I want to know the parameter that we optimize. Fine, yeah. But at the beginning, it was just a question to play to, if I give you this number of unit on this one, this number of unit for the layer 2, this number of units for the layer 3, and so on, you should be able to very quickly to tell me the number of parameters. Make sense? But
when you say,
yes?
when you say like 1 and 2 layer models, is that one hidden layer models or?
No, it was on this example. On this example, I have which is called is how many hidden layers we have in this example, in this code. One, two.
Yeah, so they're all hidden layers.
Sorry?
They're all hidden layers when you specify the number of units, right?
No, because this one is not a hidden, but is the output layer.
Oh yeah, that's the output. Okay, yeah.
But is the number of layer of the model the output count of the number of the layer. So in fact, this model will say 1, 2, 3, 4 is a 4 layers model. But
yeah,
when you say a 4 layers model, keep in mind that a 4 layers model in the language is meaning that we have 3 hidden layers.
Yeah. Okay.
So you can play with the multiplication to count the number of parameters. It could be a kind of question on a quiz, but it is not. But it could be. We give you a model and tell me how many parameters I have. Okay, so we can explore this batch normalization. Is there an effect on our 9 models, which was our goal? So it's similar code as previously. So it just the only thing I insert each time this layer batch normalization. Okay, make sense? And ugly code, and I got this. So you should be able to get something similar. Maybe it's quite long, Mhm.
Just to understand the plot completely.
Yeah.
So we are now comparing validation with validation, right? Where one of them has a batch normalization, the other doesn't, right?
Yes, we try to see which model gets the minimum validation error. Yep. Yes, the code was not so good because we put also in my code I put also I took the minimum of validation error or yes. This is with batch and without batch normalization. So in fact, most of the time the batch normalization is getting better, is improving. Yep. Maybe not a lot, but it's improving. You managed to run this code? Was it okay? Yeah, okay. Okay, so we have seen that in this example, the batch normalization help. And we still have our best model is still have large model and is around there. Huh? In fact, the minimum for me, it was, it's still this one, but very close to the large one. You can see? Okay, so what is about the regularization? When I say regularization, is the meaning that we can add at the loss function of the training some regularization term, so it's called a penalty term, which could be L2 or L1. You remember this? And this is called the weight decay when you use L2. You remember? So in this process, is help us also for not overfitting. So in this case, just to add this is to add with this function. You can see it. Kernel regularizer. And if you choose L1, you can put L1 and I put L2. And inside the bracket, you have a value, and the value, this is the value in the penalty term. Remember, it's a penalty term, you have the log function plus lambda and the norm of the norm 2 of the weight. So this value is a learning is a tuning parameter for the regularization term. Make sense? But somebody can tell me why you put 0.01. It also is a new hyper parameter. So normally we choose something small, but you can also do a grid search and to see which hyperparameter for the regularization term will be the best in your optimization process. Okay, so by default I put 0.01, and the task it was present the result for your model with 3 layers and with this number of nodes. So this is your task to do, and you should have this result, something like this, close. And you will tell me if the L2 improved your model. After we have the dropout. And after dropout, what do you have? It's minimization weight. And after we have the early stop. Oh my god. And you have the final task. It's a lot. I know. I'm very optimistic. But I've seen, at least we have seen all we have seen in the course. Okay, so you managed to get something or not? Oh, my task is easy because it's 3 layers. Is exactly this one, in fact. Plop, 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 plop. Is this one, in fact, this task? I choose the same task I put here. Is it? Is in fact it is this model to run. You agree or not? Yeah, okay, so you got this? So is the L2 penalty improve your model or not? It doesn't look now an overfit problem. You remember last time when we have a large model capacity, it was like, whoop, it go up. But now it isn't overfit because the training data, your loss function keep going down and the validation also keep going down. We don't have this effect going up. So the L2 improves your model in this case. Is it or not? Agree or not agree? Maybe not.
Well, the accuracy is worse.
The accuracy is worse on what?
On this one compared to the first model.
How was the accuracy on the first model?
It was the validation accuracy I used. Which one? Yeah, so it's close, but it's 0.9773 for the first one.
The first one? Ah, okay. And it was at 25 epoch or not? Because this is at 25 epoch. Maybe it's not the smallest.
It's 25, the other one as well.
Okay. Which figure it was?
Figure 1, the first figure.
Ah, but figure 1, it was not the model with 3 layers.
Oh, no, that's right.
4 layers. Yep. Yes, figure 1 is 1 layer more. Yes.
Okay. Yeah.
So it just want to show that if your model are more capacity, you are more tendency to go to the overfit, and if you put the relation, yeah. Okay, good. Okay, so we did the regulation. So now we want to do the dropout. Remember what is dropout? Yesterday we have seen a dropout. So you randomly put some unit to 0, inactive some unit to 0 in the learning process at each MIDI batch. Okay, so for 1 MIDI batch, you do flip coins, flip coins, flip coins, put some unit to 0, go back propagation step. Another MIDI batch, again, and so on and so on and so on. So the dropout, you can do some dropout where you want. You want to put on dropout for the first layer, second layer, third layer. So here I put a layer dropout after each step, and I put 20%. Yep. Okay. And I try to compare this 3 model. I try to compare a baseline model, so without anything, a model with the batch normalization, and a model with dropout plus batch normalization. For the model we have decided, so the model with a higher capacity. So is the meaning we have 3 hidden layers and with this number of them. Okay? And we see if it helps or not to do the dropout. I think you don't have any task to do this one, it's just to run this, and you should have this and give me some conclusion about this. So. You manage to go to something like this. So what do you think? You can see that the first one, yes. So the first one is clearly overfitting. Training going down, 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 and the validation going down, and after up, it's going up. Okay. If you put a batch normalization, is help, in fact. But it doesn't improve too much the, is help, but it's still overfitting because it doesn't move. But the last one, in fact, you can see that is getting good. And in fact, we want to stop around between 10 and 20. Yes, around 10 epoch, we want to stop. Because the validation still start to be a plateau. So between 10 and 15, you want to stop. Okay? So now we want to play also again about the initialization of the weight. Remember yesterday I tried to talk about the initialization of the weight, and by default we need to check. I think yes, the default is here because we didn't specify anything. So you have a default, and the default is called the Glorot uniform, which draws some weight between -a and a, and this a is 6 divided by the number of input which is in and out of the layer. So this is called the Glorot uniform. But so be careful, because sometimes when you use Python or another package, they will have another default initialization, and the initialization is quite sometimes very important. So if we want to put a random normal initialization, you need to put as argument kernel initializer with random. So all of these parameter, you have this. If you put question mark on layer dance and so on in R, you will see all the options. You don't need to know by heart. You can see the option in R. Okay. So I put some initialization, the random normal, and I'm doing this, and I have. So it's very difficult to see if we have a big difference with the random or not. So this is with the normal, from the normal, and the before, the one we had before, it was with the uniform. So my question is, do you see any differences? Is it better? Very hard to see because the graphic is there. So what is the best here? It looks like it's the best, huh? The accuracy is better, 98, 12 on the validation. And I think before it was, I don't know, it was, I don't know, in this one we should plot the accuracy. Validation error would be validation error with the bottle lost 0.067. Yes. But this is not the minimum. This is not the minimum, is at the end. So the last thing to see, I think, yes, it's good, is what Anne suggested at the beginning, which is called the early stop. So the early stop is a process by stopping, because sometimes you know, if you run, you don't know when it will converge, so you try with small number of epoch, you check, and after you're going further and further and further. But sometimes it's very long, and you want to stop before, because your algorithm doesn't improve anymore, or it starts to overfit. Okay, so it'd be too long to also to process. So this function early stop and this process is doing by a callback early stopping and with an argument with the patience, which give you the number of epoch to stop after your loss doesn't improve after 5 epoch. On the validation. So it stopped to train after 5 epoch after the loss haven't so if I'm doing this run, I put epoch 35 until 35. This batch size, same as I put a dropout. I changed completely here in this example. I put dropout 0.4, a dropout 0.3, 0.2, just to tell you that you can change the dropout for it can be different out for different layer. And what I have done also here, just to play quickly, I put a batch normalization after. The initialization is a random normal. What else? And a callback early stopping. And if you do this, you will see that on the plot, it stop there. So we are stopping after, I don't know, 15 epoch. So it's a meaning that after 10 epoch, he hasn't improved. Yep. And you have the last task to do for you is to present for the final model the confusion matrix and the accuracy. So this is your final task. And I got this number for me. I don't know if you got something like this, but I got this one on the, of course, on the test set. So I want that you play with the predict function and all this to get the test set. On the test set, I got this now, my final model.
Benoit, I have a question.
Yeah, of course.
So it seems like a good idea with the early stopping to not overfit. But if we look at, you had 0.271 is the task, it's just before the dropout, there's a plot looking like the plot you just showed. If you go further up, like it's plot like that, but it's not that one. It's the one with the regularization, the L2 further up.
This one?
No, so it's under 0.271. Oh yeah, that one. So if I look at the loss function here, it seems like the loss is quite unstable because of the regularization. Would it then be a bad idea to have early stopping? Because it looks like it has a minimum around 10 again, and then another minimum that's actually lower at 15, and then at 20, and maybe also at 25. So that would maybe not stop around 10 or 15.
There, yeah. Okay, so you know the minimum is like just 1 point, eh?
Yeah.
So yes, there's some randomness here. Just mention. So what do you suggest?
I don't have a suggestion. It's just a question if it's a bad idea maybe to mix regularization that has this randomness together with early stopping, because it seems like it stopped early a lot of places.
Okay. So the solution of Anne is in fact in this model, you're right. I haven't used the regularization.
Yeah, you use the dropout instead.
Yeah.
Yeah.
But you can use the dropout and the regression.
Okay.
To see if he is better or not.
Okay.
I think so, yeah. So you can see that there are many, all of this is kind of hyperparameter. It's not the parameter you optimize. It's just like you try and say, oh, this is better, and so on and so on. So it's a meaning that is one of the reasons why we split the data in three, because the validation test help us to choose between all these kind of models. So in fact, at the end, we have optimized around all the hyperparameter we have tried, okay? So we cannot say at the end, my model have this accuracy based on the validation test, validation set. So it's the reason why after, when you have decided our best is this one, finish, we have just one best, we try on the test set. And you can say, my model has this accuracy, as this is able to detect this accuracy of image and so on and so on. Okay, because the test set is just used for your final model, not to choose between the models. Is a validation test set which is used to choose between all your models.
So in practice, would you try with other activation functions other than the ReLU?
Yes, it could be also, is also another way. Yes, it's a good, is Josh who say this? Yes?
Yeah.
Yes, of course. We can also use another activation function. You can try maybe something like, I don't know, the sigmoid on the hidden layer, but
do you tend to notice big differences?
Yeah, but
in the activation functions, or
the activation function now is more popular to use the ReLU or the Liquet due to the vanishing gradient if you add a lot of layer, in fact, and the ReLU give a good result now. In fact, it is more popular than the sigmoid due to the artifact that the sigmoid like as a plateau at 1 and at 0. So it makes more sense now to use ReLU on the hidden layer. But it's a good way to have a try to see if it changes completely. But I think for this example, in fact, this MNIST is quite simple to classify. So I think with the sigmoid, it's a good point. It should work too. Yeah. Okay. I'm quite a little bit sorry because I have a meeting with Amzi now at 1:30. We are done. Any question? But I have my consultation hours today at 4. For us who want to ask some question or on the prac or on the course. So I'm still online at 4 to 5 today. All good? Okay.
Thanks, Benoit.
If I don't, thanks, Matt. Are you okay, Matt? Because it's your first time in R, you managed to get it to go through?
Yeah. I'm okay.
Are you okay?
It's a lot, but I'm okay.
Yeah. What kind of language did you use to go in maths? You do some MATLAB or some?
Mainly, mainly MATLAB.
MATLAB, okay. Yes, for algebra, for the matrix and all this in math applied. Okay.
Yeah.
Okay, all good. Who is your partner, Matt?
Anne's my partner, so it's very good because she's excellent with R.
Yeah, good choice. Good. Perfect. Okay, have a nice weekend. For us, I don't see you. Good luck for you have I think a quiz this weekend, and I think we put online the homework too. I think this weekend too. We are working on, and you have a tough week again with the conversion part, blah, blah, blah. And I think there are some what's his name, a bank holiday or whatever next week. Is it? Is Tuesday something like this? Is it? I don't remember. I see Tuesday 26. Okay, 26 you are wow free. Oh, good. Okay, and I think I see you on 28 and 29 something like this for trick of the trade. I go very fast. Okay, keep going. And have a good weekend. Hot weekend. Pretty. Bye. Bye, Josh.